Welcome to SUNY New Paltz CAD Resources. This channel will hopefully help you learn the Rhino 3D software and complete the weekly homework assignments for CAD 1. Let's get started. For this video, we're going to be replicating this 3D printed cube, using our calipers to take measurements, and then drawing the object in Rhino. I'm going to start out by taking some measurements of the outside dimensions of our cube, and then I'm going to measure the height of this platform that makes up the bottom half of our cube. Using our dimensions, I'm going to use the box tool to create the platform. And to keep everything organized, I'm going to create some layers with different colors just to keep my final object separate from any construction geometry that I create during the process. To create the geometry that's on top of the platform, we can break these shapes down into a sphere and a box that's been sliced. I need to get some more measurements, but I already know that the height of this box is going to be the distance between the platform and the overall height. Once again, I'm going to use the box tool. I'm going to be sure to use my O-snaps to snap to the top of the platform, and I'm going to enter my dimensions that I measured in the command line. Now we have two boxes, but they're not actually joined together yet. To join solids together, we need to use a Boolean union operation. Next, I want to create a surface that will allow us to cut off this piece from our object. We can create this geometry by using our surface from 3 or 4 points command. Using our O-snaps, we can place the corners of the surface at the end points of our cube. And you can see that this is a solid surface, not just curves. And now we can do a Boolean difference operation to subtract that part away from the solid using our surface. Unlike Boolean union, the order you select objects in Boolean difference does matter. Next, we're going to create a sphere at the top of our object. The easiest way to do that is just by using the sphere 3D primitive, and again using our O-snaps to start the sphere at the center of our platform, and then dragging it to a midpoint snap on the edge of the platform. Next, we can use a Boolean union to join these all together, and notice how using the different layers with different colors helps make it obvious when this is all joined into one solid. The next geometry that we're going to create are these through holes that have a circle opening on one side and a polygon opening on the other. To measure the length of the edge of the polygon, we need to use the inner probes on the other side of our calipers. Make sure that within the polygon command you select edge mode to set the length of the edge, and you use the ortho snap by holding down shift when you're placing the end point of the line. Next, we have to position our polygon into place. I'm going to start by using the align command to move it to the bottom of the cube. Then we have to take some more measurements to determine how far in the different dimensions we need to adjust the polygon. I'm going to use gumball here to precisely move the polygon up and over by the amounts that we just measured. Now we need to take some measurements of the diameter of our circle on the other side of the cube to make the shape of our cutout. You want to make sure whenever you're measuring a 3D printed circle that you take multiple measurements just to be sure that there's no discrepancies in the different dimensions. For the purposes of this demo, I'm just going to assume that the circle on the other side is centered relative to the polygon. So I'm going to use my center snap to draw it in place using the measurement we just took as our diameter. So we have both of our curves that we're using to create this surface on one side of our object. So we need to get the circle to the other side of the cube. We could use gumball to do this, but I'm going to use the move command, which allows us to select a start point and an end point for our transformation, and I'm going to use the endpoints of the cube to determine that movement. Now we have our circle on the other side, and we can create the surface that will be the cutout. To create this surface, we're going to use the loft command, which creates a surface through a series of curves. Select the curves, enter loft in the command line, and press OK. And I'm going to turn on the wireframe view, and you can see now we have a surface going through the whole length of our cube. that starts as a polygon and ends as a circle. Now we can do a Boolean difference to subtract away the lofted surface. First select our object, then select the lofted surface, then press enter to complete the command. Now we need to make the other cutout on the other side of the cube. Measuring this inner length here of the triangle is a little tricky because the edges of the triangle will get in the way of your calipers if you stick them in too far. So you want them to be basically just at the edge. Just like last time, I'm going to draw my polygon in edge mode, starting at the corner of the face that it's going to be on, making sure to hold down Shift to snap it to ortho. Again, we're going to take some measurements to see how far this triangle is away from the corner. Again, this can be a little tricky because the edge of the triangle gets in the way of where your probe has to be, so you want it to be just barely inside so that you get a good measurement. Now that I've got my measurements, I'm going to use Gumball to move the triangle up and over from the corner so that it's positioned where we want it. I'm going to take some measurements of the circle on the other side again. I want to do more than one measurement, just rotate it around a little to ensure that I'm getting an accurate reading. Again, for this demonstration, I'm just going to assume that the circle is centered on the polygon. In the actual model, that may not be the case, but I'm just kind of skipping over that because you don't really need to see it again. Once again, I'm going to use the move command to get my circle onto the other side of the cube, using the two endpoints of this edge of the cube to get that distance. Again, we're going to use the loft command to create a surface between those two curves. And then finally, we can do a Boolean difference to subtract it away. Hopefully this video was helpful. It doesn't show you everything that you need to do to replicate the cubes that you currently have this semester, but I'm hoping it gave you a bit of an idea of how to approach something like this and some of the commands that are useful along the way.